All right. Welcome to Geometry, Unit 1, Lesson 21. And your learning target today should be, you can say, I can use midpoints and bisectors to set up algebraic equations and solve for missing variables. So today we're going to get good at using midpoints and bisectors, understand what those mean, apply that, and then use our algebra skills to then find missing information, find missing variables. Your paper that I printed out may not have this exact learning target on there. I may have neglected to change that, but if you want, you can write this in. You can write the learning target in if that's important to you, or you can just keep in mind today where the actual learning target is I can use midpoints and bisectors to set up algebraic equations and solve for missing variables. Let's begin. All right, again, with geometry. Geometry is different than algebra. Geometry is a lot more about reasoning skills, about puzzling things out, about using definitions and information you already know in your head, and then somehow applying that, teasing that information out to find new and other information given certain assumptions. So, unlike algebra, geometry is just filled with terminology you kind of have to memorize. You have to master it in order to be successful. If you don't know what a bisector is or what a midpoint is, if you don't know the definition of that, if that doesn't really make sense to you, on a test question, you're not going to be able to answer that question. Without knowing the terminology, you're not going to be able to answer the question. So we need to get good at this technology. So you need to not only memorize it and internalize it, um, but you need to really make it part of you. You need to have the meaning really feel solid and good. All right, it needs to be very meaningful for you. We've already learned collinear. Collinear are points on the same line. They're collinear. They're on the same line. Co-workers. We learned complementary. Those are two angles that add up to 90 degrees perpendicular, right? And we learned supplementary. Two angles that together add up to 180 degrees because they're on the same line, or at least could be on the same line. So today, here's our first new geometry term. Our new geometry term here is midpoint. A midpoint is the point on a line that divides into two equal segments of length. So a midpoint is the point on a line that divides it into two equal segments of length. All right. So the midpoint is the point in the middle. We've already talked about this a little bit, but now we're going to be doing it on a little bit more in depth. Nah, last but not least, or yeah, second of all, we have our segment bisector here, right? So a segment bisector is a line or a ray or a segment that passes through the midpoint of another segment. So if you see a segment bisector, the segment bisector is going to intersect with a ray, a line, or a segment at the midpoint. So it's going to, whoop, sorry about that. Didn't mean for that to happen. And I'm playing with my technology here, trying to write and draw things. Write and draw things on the screen, right? This is me manipulating the mouse with my pen and my digital pad. All right, an angle bisector. An angle bisector is a line, a segment, or a ray that divides an angle into two congruent angles, two angles with the same measure. So an angle bisector, a bisector, is going to cut the sector into two. Bisector. It's going to cut the angle into two equal parts. Just like a segment bisector cuts a segment into two equal parts at the midpoint. An angle bisector is a lot like a midpoint, but we're cutting angles instead of segments. And then, so this angle bisector, we're cutting angles into two equal parts. Segment bisector, we're cutting segments into two equal parts. Midpoint, we're cutting segments into two equal parts. And now perpendicular, something a little different. Perpendicular are any two line segments or rays intersect to form a strictly 90-degree or right angle. So we've talked about this a little bit, but we're putting it in our vocab sheet today. For instance, we can say that like AB here, line AB is perpendicular. That upside down C there is a symbol for perpendicular, is perpendicular to line CD if the two lines AB and CD form right angles. All right, so those are our definitions. These are going to go into the vocab sheet on the next page in future lessons. So watch out for that. Those will always be there for you to refer to as we progress in the unit. And then after we go to Unit 2, we'll restart and start with new vocab. So exercise 1. Exercise 1, it says, in the following exercise, you will work with the definition of a midpoint. All right? In the following diagram, use measurement to determine if H is the midpoint of FG. And I want you just to look right now of this FG segment. Does H look to you like it's the midpoint, like it cuts it directly in half? And I'm kind of hoping that just by looking at this, you're going to tell me, no, Mr. Solt, FG is 4.07 in length here if I measure this here. But if I measure H, I get 1.78. Well, let me use my tools here. Oh, that would be a great extra tool to have as a calculator. I think we'll try that. Let's try that here. Calculator. Nope, not calendar. Calculator. Oh, we can use this. That's nice. All right. What did I get? I got 4.08, right? 4.08 was the measurement between F and G here, right? Between F and G, I got 4.08. If I divide that in half, that should be the length. 2.04 should be the length of my midpoint, right? But did I get that? No, I got 1.78, right? 1.78. Oh, no, that's not what I wanted. Sorry, I have to switch back and forth between tools. 1.78 is what I got. And between here and here, it's going to be not 1.78, but it's going to be like 2.31. So do you see that? H is not midpoint here because it's not directly in the middle between FG. The directly in the middle between FG is going to be somewhere at 2.04, right? So right there, right here is going to be the midpoint. H is off. All right, let's go to part B here. Using measurement, locate point C on part AB at its midpoint. So we're going to use measurement to find a midpoint. Let me measure. Again, I'm using this digital ruler here. I'm getting a measurement of 3.73. 3.73. Let me bring up that calculator again. 3.73. What's the half of 3.73? Clear. 3.73 divided by a half gives me 1.86. Well, I'll call it 1.87. We'll round up there, right? 1.87. We're going to get real precise here. 1.87. So I need, let me try a different color there. $1.87, right? 1.86. We said 87. Okay, there we go. Perfect. There we go. Oh, nice. There's the midpoint right there, halfway in between A and B. We can call this point point C. So let me try to call that point C. Oh, all right, yeah, I'll pick that color. Thanks. That's point C. All right, again, sorry, I'm still struggling with with the drawing pad here and using this pen. What equation can we rewrite? What equation can we write about AC and BC at this point? Well, couldn't we write that AC? Ooh, no, that's not what I wanted. AC, stop that now. AC is equal to BC, right? If C is the midpoint between A and B, that makes BC equal to AC. If this is the midpoint, it cuts this into two equal parts. So AC is going to be the same length as CB because this cuts it directly in half. AC is going to be equal to BC. Does that make sense? Well, you've just actually kind of partially hit your learning target. If this makes sense, if you've learned this, if a midpoint cuts a segment directly in half, it creates two equal segments, which means the two parts that it cuts in half be set equal to each other into an equation. And that's really where we want to get you. We want to be able to get you to use a term like midpoint and set up an equation. Now, sometimes they'll give you like AC equals 5. And then they'll say, well, what's BC? Well, if AC equals 5, well, BC equals 5. If AC equals 5x minus 4, then BC is going to equal 5x minus 4. We'll get in more into that in a second. Let's move on to exercise 2, shall we? In the following diagram, C is the midpoint. So in the following diagram, C is the midpoint of the line segment AB. There's AB, and there's C right in the middle between them. Then it tells us that D over here is the midpoint, between BC. So D is the midpoint between C and B here. And then E is going to be the midpoint between C and D. So E is the midpoint between C and D, all right? And then they give us like one of those little crucial pieces of information. They tell us, I'm going to cough, hold on. They tell us that ED here is going to be equal to, so this here, that piece right there, is going to be equal to 5. They tell me that right there. ED is equal to 5. Now I have to determine the length of AB. You know what? I'd like you to stop the video right now, pause it here, and see if you can figure out the length of AB, because I think you have all the skills to be able to tackle this right now. Especially if that last one made sense to you. Pause the video here, give this a try. Remember, we learn by making mistakes. This is a great one to make a mistake on because it's easy to fix, and you're going to do great. All right? Give it a shot. All right, well, hopefully you're now the video is being unpaused because you gave this a shot. Well, let's think about this. If ED is 5 and E is the midpoint between C and D, then that makes CE 5. All right? Okay. Well, now I know that CD, the total part, these two things together are going to give me 10, right? Between 5 plus 5 is 10. Well, if okay, not bad now. If CD is 10 because 5 and 5 is 10, then DB is going to equal 10 because D is the midpoint between C and B. If D is the midpoint between C and B, then CD equals BD, and if CD equals 10, 5 plus 5, then BD equals 10. You feeling that? Okay. So now I want to find out what AC is. Has anyone figured that out? It's going to be the total length of CB, because we were told that C is the midpoint of AB, right? If C is the midpoint of AB, then CB is going to equal to AC, which means I just add up 5 plus 5 plus 10. That's 20. That's 20. So now this is 20. Sorry that 2 is awful. All right, so then what's the length of AB then? So length of AB equals 20 plus, I could add all these up at a time, 20 plus 25, 20 plus 5 is 25, 25 plus 5 is 30, 30 plus 10 is 40. I could say it's equal to 40. Honestly, if I know that this part is 20, and I know it's half of the whole thing, I could have said 20 times 2 is 42. That would have been a quicker, easier way to get through. Give me this smiley face reflection as to how you're feeling about this. When you did this on your own, was this smiley face easy? Yay! Was this sad face? I'm lost. You set me on my own too soon. I didn't know what to do. Or are we somewhere in between? Like, oh, I got some of these. I figured out this one was 5 maybe. And then maybe it took me a minute or two to figure out this was 10, but then I got lost. Maybe you're somewhere in the middle there. That's okay. Give me that smiley face reflection. And let's move on. Let's practice some more of these. All right. Exercise 3. Exercise 3. In the diagram below, segments AB, and segment DE intersect at point C. Are either segment bisectors? So is either segment the bisector of another segment? Well, as I'm looking at this, I'm looking at DE, and C is definitely not in the middle of DE. I'm just eyeballing that, but I'm pretty certain that C is not in the middle of DE. However, as I look at this AB, C looks like it could totally be directly in the midpoint of AB. So it's possible that DE is a segment bisector of AB. DE bisects AB at point C. We might be able to say that. So let's look at our statements. DE bisects AB. Justify. Does DE bisect AB? Well, we could measure this. We could measure this to say this is 3.94. 3.94, all right? If that's 3.94, then I bring out my handy dandy calculator. 3.94 divided by 2. What's the half in between the whole? The whole is 1.97, okay? 1.97. So when I measure this other half, I should get 1.97 if these two things are, well, yeah, I think that is just about right, right? 1.97 is halfway, and I bet you this one will come really darn close too. Again, there might be some imperfections because I'm measuring to such I'm measuring to like hundredths of whatever unit is this electronic ruler is using. Yeah, I'm going to say that C is totally a bisector of DC. So I'm going to say line. Oh, I need to go with my pen. Line DE sorry, this is awful, isn't it? I'm gonna have trouble writing this because I'm not gonna be able to write that tiny with these tools. DE bisects. Oh, that was awful. No. Bisects. When I press too hard, it brings up a menu. I don't want the menu. DE bisects AB, and if I go too fast, it won't recognize it. Because, oh, I need to go with a different tool. I'm frustrated. Are you frustrated? Let's try a different tool. Nope. That's not the tool I wanted. What is the tool I want? Sorry about this, folks. I thought I could just put this on top of that. All right. That's what I was looking for. DE bisects AB. And I need the little line above these two things because C is the midpoint between AB and DE intersects at point C. So that would be like the big, full, wordy explanation. DE bisects AB because C is the midpoint between AB. We confirm that with measurement. And DE intersects at point C. Therefore, DE is the bisector, segment bisector of AB. And does AB bisect DE? Does AB bisect AD? Well, I think we're going to take our ruler out here and we're going to see that these are not the same. This is a distance of 1.45 and this is a distance of 2.62. Wildly not the same. Wildly not the same. So we're going to put our little box in here. AB does not bisect DE because point C is okay, not a midpoint of D. There we go. AB does not bisect E because C is not a midpoint of DE. All right, if you need more time, pause the video there. I'd like to move on. Exercise 4. In the following exercise, we're going to work with the concept of angle bisectors. All right, so we have a question before us. Does AG, this line segment here, does it bisect BAD, angle BAD, right? Use measurement to justify your answer. Okay, measurement to justify our answer. Well, to measure, we're going to use a protractor. And I'm not sure if I'm quite up to using my protractor yet, but let me try. All right, I'm moving my protractor. Ooh, I can make my protractor different sizes. That's pretty neat. All right, moving the protractor. I want to first figure out what is the total angle measure of this angle. Total angle measure of this angle. Make sure I'm right on there. You know, I was really hoping that was going to come up with a really nice angle, but I guess we'll have to deal with what we have, right? I was hoping that was going to come up with a nice 50-degree angle, but it's definitely not exactly 50 degrees. It looks like it's 47.2 degrees. So we're going to need our calculator to figure out what 47.2. Let's see what's half of 47.2. 47.2 and divide it by half. Divide it by 2. 23.6. All right. So we will know that this is an angle bisector if we get a 23.6 or something close to 23.6 angle measure out of these other two angles here. Let's measure these. I'm going to put this right there. Make sure I get that good. Is it going to be 23.6, folks? 23.6. Oh, look at that. 23.6. Let me use another tool just to zoom in case nobody believes me. 23.6. Exactly what we thought it would be. Measuring pretty precisely. And me showing off all my fancy stuff going on. Yes, both of these are 23.6. Well, actually, someone might say, well, Mr. Salt, are they both 23.6? Oh, you had to throw that at me, didn't you? We probably do. For the sake of being accurate, have to make sure that both angles are 23.6. Although really, we know that if this one's 23.6, and we know that's half of the whole angle, we know that the remainder has to be 23.6 too, right? Okay, well, I'm sure there's a measuring error going on here, but I'm getting 23.8. I'm going to call that close enough. Close enough, all right? So they're both 23. We'll meet it somewhere in the middle. 23.7. How about we say that? 23.7. Okay, protractor, you can go away now. Nope, I didn't want a second protractor. I want you to go away. Thanks. You've been a great help. All right, so they are 23.7. That was, I think, our compromise. 23. Oh, that's an awful 3.7. 7. This is embarrassing. This is like a toddler where I was writing these numbers. 23.7 degrees, 23.7 degrees. Yes, we can say that that AG is let's put that in there. AG, we need a line above AG, is an angle bisector of angle BAD because both angle BAG and GAD are the same measure. And if you want, you can say you could say they're both 23.7 degrees, if that makes you happier. So pause the video here if you need more time to write that down. Let's do the next one. B, use your protractor to draw a angle bisector of G shown below. So we need to use our protractor to create an angle bisector. Let's do that. Bring that protractor back. There's our handy protractor. We'll lay that right down where this point here is on the vertex of my angle. And there, I'm being too persnickety. I don't need to be that precise. All right, now I'm going to measure my angle. That's a nice angle. I'm going to call that exactly 110 degrees, okay? If you see that, 110 degrees. I know it's not lined up precisely with 109.9. Yeah, I'm going to call that 110. That's close enough to me. So 110 divided by 2. Can we do this in our head? That would be 55, wouldn't it? If you can't do that in your head, that's okay. Use your tools. So boom, right there is my angle bisector. This is a 55-degree angle. I just need to use a pen to kind of mark that point. There we go. And now I'm going to remove my protractor. And now that I've removed my protractor, I'm going to connect my point to my vertex. And now I know both of these are going to be 55 degrees. The whole angle is 110, measured with a protractor. And each little piece of this is going to be 55. Oop, that's not what I wanted. 55 degrees. 55 degrees. All right. The whole thing's 110. There we go. Using your protractor to create an angle bisector. We measure the whole thing to be 110. We divided by 2, got 55. And then we put in a 55-degree angle measure. If this is 55 and that's 55, the whole thing's going to add up to 110. Easy peasy, lemon squeezy, right? All right, if you need to pause the video here, pause it. I think we're done. Let's move on. Measurement and construction. So in diagram below, D is the midpoint of BC. So D here is the midpoint of BC. Justify your answer with measurement. Okay, well, I'm kind of getting tired of the measurements thing. I'm not used to all this measurement. Usually I like to use a compass to do all this. But we'll do it from measurement for now. That one's 2.79. 2.79. This one is 2.79. All right. That's going to be easy. B is the midpoint of BC because, maybe if I put segment in there, segment BC, because segment CD has the same measure as segment BD. E is the midpoint of BC because segment CD has the same measure as segment BD. Okay, we've justified our answer with measurements. You could totally put the measurements we have in there. I did do that because I don't know if exactly if my measurements digitally are going to be comparable to what you see on your paper. I don't want to distract you. You use your ruler. You take your measurements. I showed you use my digital ruler. It's the same measurement. Fair enough. Let's move on. Using your ruler to measure, draw EF so that it bisects RS as shown. So we need to find the midpoint of RS and draw EF through it. Mark their intersection as point A. Mark all relevant measures to justify your answer. All right. So here I go. First, I need to find the midpoint. I need to find the midpoint. I'm going to find the midpoint by measuring the whole thing and dividing by 2. 3.56. 3.56 divided by 2 is going to give me 1.78. So now I'm looking for 1.78. 1.79. That's pretty close. Maybe I should have stuck with that. There we go. 1.78. So now what I need to do is I need to create a segment RS. I'm sorry, EF. A segment EF. Draw segment EF. See that there? We're going to draw a segment EF so that it bisects RS. So I need to go so that my segment goes through right here, right at the midpoint, right there, right at the midpoint of RS. And I need to call this A, where they intersect. I need to call that point A. Just when you think you can write tiny, it says, no, I'm not going to let you cross the A that you've written. I'm going to pop a menu and just annoy you. Oh, please let me write E, F. I'm sure when I get used to this, it'll be really easy. Just gotta get used to it. I'm sure. All right. Now let's see. We marked the intersection as point A, and oh, we might have to put measurements. So I forgot what I said. That's 1.78. 1.78. Right. And if that's 1.78 and I was half of the total, then this side too has to be 1.78. Must point A from point 2 be the midpoint of EF? Do we think A is necessarily the midpoint of EF as I drew it? No, it doesn't look like it is. AF looks longer to me, just eyeballing it, than EA. No. So just because EF cuts RS in half doesn't mean that RS cuts EF in half. You know, I'm going to use the little typing tool to put that in there. No. Just because EF bisects RS does not mean that RS bisects EF. There we go. There we go. That's our justification. When it says justify, we're given the reason why. Why or why not? No, and we give a because. So that's our justification. Pause the video here if you need more time. All right. Number 4 here. DF. DF is an angle bisector of HDJ. DF is the angle bisector of HDJ. As soon as it gives me this information, you know what? Once I have that kind of information, I'm going to be able to, oh, no, I want that back. And I'll delete all that. And so I want to make this little marking. Arc mark here, arc mark here. It tells me that these two angles are going to be the same. Why? Because DF is an angle bisector of HDJ. DF bisects, cuts this whole angle in half. If it cuts the whole angle in half, it creates two equal halves. All right? So, oh, it asks me, I read carefully, is DF an angle bisector of HDJ shown below? Justify your answer by using your protractor to measure the relevant angle. So we're going to see if this is the case. We're going to see if this is the case. This one, I wanted something different. Here's my protractor, measuring the angle. All right, that's pretty close, but I could get a little bit better. That's better. Measuring this angle here, that looks to me to be 22.5, maybe 22.2. All right, 22.2. And now I'm going to put my, oh, look at that. When I turn my protractor and line my protractor up here with this next line, notice that my 22.2 falls very much short of coming to J, which means this one, the other one was 20.2, right? Right? Was it 20, 22.2, 22? This one's going to be 28.4, or maybe 28.3, right? Move that back over to my original line. Notice how this angle here is so much bigger. So, just eyeballing this, it looked to me like this one could be the same angle measure as this one, but when we break out the protractor, we can see these are two different angle measures, in fact. I can get one arc mark here, but then I have to make two arc marks here, because these are two different angle measures. So this one's 28.3, right? 28.3. 28.3 degrees. And what was the other one? I don't even remember. Let's measure again. 22.6. 22.6. 22.6 degrees. All right. All right, if you need this video longer, pause it, moving on. And now we have the check for understanding. Check for understanding. In the diagram below, which is not drawn to scale. What does not drawn to scale mean? Not drawn to scale? That means that you can't rely on your protractor anymore. All right? But we do know that AB here, is going to be perpendicular to AD, which means we have this little symbol here, which says this is a 90 degree angle. If the measure of CAD is 3 times the measure of BAC, whatever this is going to be 3 times this angle measure, determine the measure of CAD. Let us set this up for you at least, all right? So I have, this is one angle measure, this is a different angle measure, so I get 2 arc marks, and they don't tell me what the measurement of this is. We'll call it X. I know this one's 3 times whatever the other one is. If this is X, this is 3 times X. So pause the video here and think about how you're going to set up an equation. We've done lots of things like this. I hope this will be easy. Set this up as an equation. Pause the video now. All right, now you're unpausing the video because you've set this up as an equation. You thought to yourself, wait a minute, I know that this whole thing is going to be equal to 90 degrees. And I remember that part plus part equals whole, right? Hopefully, we're remembering this. Part plus part. It takes me so much longer to write this. I should have just typed it. Part plus part equals the whole. Okay, so, which means 3x plus 1x, right, just 1x over there, is going to be equal to 90 degrees. All right, well, these two are like terms. I can add 3x and 1x together. That gives me 4x when I add those together. 1 plus 3 is 4. They're both times x, so I know that's equal to 90. And hopefully by now we're getting pretty good with the algebra here to say, okay, there's a number, x, times 4 gives me 90. So to find out what x is, I'm going to divide by 4. That will cancel the 4 on this side. But if I do it on this side of the equation, I got to do it on that side because equations are balance beams. And 90 divided by 4 is 22.5. So x is going to equal 22.5. And I did that on a calculator. I did not do that in my head. Got a calculator sitting beside me. But if you want to confirm that, 90 divided by 4 equals 22.5. All right. So, that's awful. Some of the stuff didn't come back. Well, I guess you'll have to rewind the video if you want whatever didn't come back when I made it go away. We want to determine the measure of CAD. What is CAD? Well, it's 3 times 22.5. So what's 3 times 22.5? It's 3 times x, right? And we know what x is. So we're going to find out that 3x is going to equal 3 times 22.5, which if you break out your calculator, will give you 67.5. 67.5, that's your answer. Oh, and you'll need degrees, right? Little degree mark there. Boom. You just crushed this Regents question. All right, let's move on. In the diagram below, AB and DE bisect each other. If F is the midpoint of DC, if F is the midpoint of DC, and AB, the whole thing here, equals 20, and DE, between D and E here, equals 12, find the value of FC plus CB. So you'll need to find this length and this length, given what you know. I'm going to leave you to it. I'm going to leave you to do this one on your own. Give it a shot. Take some risks. This will tell me whether you get what we're doing today. This will get me whether you can use your mind and puzzle these out. Give me that reflection on how things are working for you in the classroom, what's working in the classroom or working in these videos, what needs to be improved with the classroom, with your learning, or the instruction. Tell me how things are going for you. There we're going. There's all our vocab words as we're adding to them. And, oh my gosh, almost, I worried there wasn't going to be a homework assignment today. All right, in the following diagram, CE is perpendicular to AB. Oh, if you need to stop the video and make sure you finish that check for understanding, go back and finish that check for understanding. Don't leave that blank, all right? In the following diagram, CE is going to be perpendicular to AB. So we have that to 90 degrees. CF is perpendicular to CD. This gets a little messy, but if you can see, these two are going to form a right angle. If we are given that AC equals 5, so they're telling me here, oops, no, that's not what I wanted. No, go away. Now I need to make that go away. Okay. Technology is still not perfect yet. AC is 5. They're telling me that AC here is 5. And they're telling me the measure of angle BCD is 25. BCD. This here is going to give me 25. Then we have to find the measure of angle DCE. We want DCE. We want to know what is the measure of this guy then. And we want to find the measure of ECF. ECF, okay, it's this one. I have to give it 3 arc marks because it's going to be yet a different angle measure. All right. How do we do this? Well, I know that this to here is 90 degrees total. If this piece, if this whole thing is 90, then the part plus part will equal the whole, right? If this whole thing there equals 90, then it will equal x, call it x, plus 25. X plus 25. Well, to find out what x is, I'm going to take 90 minus 25, right? I'm going to minus 25 on this side to get rid of it on this side. Boop, that goes away. Now minus 25 on this side. And I'll get my answer. So Breaking out my calculator, letting it do the heavy lifting here so I don't miss a 5. That's 65. X equals 65. There I go. Oh. All right. Well, now I have this as 65. How do I find ECF now? ECF, how do I find this one? Well, I know that ECD, which I already found, 65, is complementary to this other angle here. I know that these two will add up to 92. 65, and we'll call it Z. 65 plus Z will equal 90, right? Because they're both on a right angle. So 90 will equal Z plus 65. No, I didn't want the menu, thanks. Press too hard to get a menu. All right, well, I'm going to have to subtract 65 on both sides of this equation. 65 subtracting this side gets rid of the 65. 90 minus 65. I'm sorry how awful that looks, but 90 minus 65. I'm going to my handy dandy calculator in front of me. You go to the calculator in front of you. That's 25. All right, so Z is going to be equal. Oh, I'm never going to write this small enough, am I? 25. Okay. All right. There it is. So I found both angle measures. There I go. This one's 65. This one is 25. Do we know that AB equals 10? We're done with this question. Let's move on next. Do we know that AB equals 10? If we're told that AC is 5, and are we told that this C is the midpoint? We're not, right? There's nowhere in here that tells us that C is the midpoint. So we don't know. No, we don't. And the reason why is because we're not told, we're not given the information that C is the midpoint, right? No, because we are not given the information that C is the midpoint. There we go. Oh, all my stuff came back garbled, so we're just going to forget that right there. Okay. If you need that other information, you'll have to go back to the video and see that. That's the homework, folks. That's everything. We're done for the day. Hopefully, you can say that you can use midpoints and bisectors to set up algebraic equations to solve for missing variables. Have a good day. Remember, we matter.